Okay, this is YouTube on triangles. We're going to need some triangle math, mostly for vectors when we talk about vectors later. So anyway, I'm sure you all know what a triangle is. The particular kind of triangle I'm going to be talking about here is a right triangle, and so that means one of the angles is a right angle. And so I will always denote that by drawing a little square in one corner. So this is a right triangle that has a horizontal leg of 3 arbitrary units and vertical leg of length arbitrary units 4. And it has a hypotenuse of length h. And by the Pythagorean theorem, we know that h squared is equal to 3 squared plus 4 squared, which is 9 plus 16, which is 25. And h is therefore the square root of 25, which is 5. And so this is a 3, 4, 5 triangle. The next thing to think about is to discuss how we get the angles in this triangle. And so to do that, we're going to define 3 trigonometric functions, and it's going to revolve around this triangle that I've drawn right here. Has horizontal side x, which we'll call the adjacent side, vertical side y, which I'll call the opposite, and hypotenuse h. And then angle big A and angle big B are the two angles which are the acute angles in this right triangle. So the cosine of the angle A is defined as x over h, or in different words, the adjacent side over the hypotenuse, adjacent to the angle. The sine of A is the side opposite A divided by the hypotenuse, y over h. And the tangent is y over x, or in other words, it's the opposite divided by the adjacent angle. So for each one of these trig functions, there's an inverse function. So if cosine A is equal to x over h, it means that A is equal to cosine minus 1 of x over h. That's sometimes written as a cos, arccosine of x over h. This is generally read as the angle whose cosine is x over h. Or one could also say that A was sine minus 1 of y over h, or the arcsine of y over h. Or it could also be calculated as the tan minus 1 of y over h. That's a typo there. That should be an x. Y over x, in other words, the opposite over the adjacent. A tan of y over x. And so those are by definition. And we will, for special angles, except for special angles, unless you if you don't know what those special angles are, we'll always use a calculator to find the angles here for either a tangent or an arctangent, or similarly for the other functions. So going back to this original triangle here, one could calculate the A by either taking the inverse tangent of 4 over 3, or the inverse sine of 4 over 5, or the inverse cosine of 3 over 5. And so let me do that by going over to the little scientific calculator that I have. And one thing you'll want to do here on your calculator is to choose degree units, which are the units I'm going to be using for angle in this segment of the class. And so if I want to know what tan minus 1 of 4/3 is, so in this calculator it's a tan instead of tan minus 1. 4 divided by 3. Okay, so that's 53.1 degrees. I'll write that in here. Equals 53.1 degrees. Or I could also have calculated it as an inverse sine. And so that would be an a sine. Going back to the calculator here. A sine of, okay, it's a sine of 4 divided by 5. Which is the same thing, just a different way of calculating the angle. Or I could also have done the angle whose cosine is 3 over 5, or in other words, cosine minus 1 over 3 over 5. On my calculator, that's going to be an a cosine of 3 divided by 5. And so that also is going to be 53.1. And so all up and down here, I get the same thing. Same thing. So this same all the way up and down. Now for angle B, I could do a similar thing for angle B. If you look at angle B, for B, the opposite definition of tangent is always the opposite divided by the adjacent. And so for B, that would be 3 divided by 4, which would mean B is equal to tan minus 1 of 3 divided by 4. And so if I go over to my calculator here, I'm going to do an A tan of 3 divided by 4. I get 36.9 degrees. Let me just write that in here. 36.9 degrees. That could also have been calculated with an inverse cosine. So a cosine on this calculator of 4 over 5. And you can see that's the same angle. Or as an inverse sine or an a sine, in other words. A sine of 3 over 5. Okay, and again, 3 different ways of calculating it, all getting the same number. And so that's calculating A, B. In fact, I really didn't even need to go through using the inverse trig functions for B, because once you know what A is, 53.1, B is just going to be the complement of that angle. In other words, the angle which take this and subtract it from 90 to get this angle. You can see that this plus this is equal to 90 degrees. In other words, I'm saying that for a right triangle, A plus B is equal to 90 degrees, and therefore B is equal to 90 degrees minus A, which in this particular case would be 90 degrees minus 53.1 degrees, which in fact is the same thing we calculated with these ratios definitions over here. Okay, so let's take another example. Let's say you had a right triangle like this, where we had, in this case, we didn't know the 2 legs. We knew one of the legs, and we knew the hypotenuse. And of course, this is a right triangle, a right angle again. And so I can find x using Pythagoras, simply by saying that 6 squared is equal to 3 squared plus x squared. Well, that means that x squared is equal to 6 squared minus 3 squared, which is 36 minus 9, and that I think is 27. And so x is then the square root of 27. So let's go over here and figure out what the square root of 27 is. SQRT in this calculator, 27, 5.2 roughly. I'll just use 1 decimal point in these calculations. And again, the units are arbitrary. So how would I figure out what A and B are? Let me just start by using the 3 and the 6, because the x was calculated. So I know 3 and I know 6. And so if I look at A, I can see that the sine of A is 3 over 6. And so the sine of A is equal to 3 over 6, which is of course 1/2. And therefore A is equal to sine minus 1 of 1/2, 3 over 6. Okay, so if I do that over in my calculator, that's an A sine. 30 degrees. That angle is 30 degrees. All right, so we know that this is 60 because these two have to be complementary, but let's use, just for practice, use our trig functions and figure out what B is using trig functions. And so I can see that the cosine of B is the adjacent divided by the hypotenuse, and so the cosine of B is equal to 3 over 6, which is 1/2. And therefore B is equal to the inverse cosine of 1/2. Again, I'm going to use the calculator here. It's a cosine of 1/2, which is 60, as we knew because it had to be the complement of the angle. Okay, so that's an introduction to triangle math, and we have the Pythagorean theorem that we've used here. I'm sure you all know about that. What might be new to you is the definition of these primary trig functions, cosine, sine, and tangent, and then the inverse functions here, and using the trig functions as you see down here in these examples to figure out what the angles in a triangle are. So we'll be doing a fair amount of this with vectors throughout the class.